The biggest cosmic encounter since Oumuamua and the world's most powerful space agencies have gone completely dark. On October 3, 2025, an interstellar comet named 3I Atlas buzzed Mars, and the only proof we have is a ghostly smudge found by citizen scientists in public data. With billions of dollars of technology pointed right at it, the official images are missing in action. So, are we looking at a cover-up, a colossal failure, or the quiet prelude to a discovery that will change everything? Let's explore this together. The flyby. So, what really went down on October 3, 2025? Imagine an object born in the dark between the stars, wandering for millions of years, finally entering our solar system. This visitor, 3I Atlas, made its closest pass to Mars at a distance of just under 0.2 astronomical units. That is about 29 million kilometers, close enough to give us the best look we have ever had at an interstellar object. This wasn't some distant blurry dot. The comet was right in the neighborhood of our most advanced robotic explorers. Experts like Dr. Casey Leese have spent their careers waiting for a moment like this. In response, a fleet of spacecraft was mobilized. NASA's Mars Reconnaissance Orbiter, the European Space Agency's Mars Express, the UAE's Hope Probe, and China's Tianwen-1 all had their schedules scrambled. Mission planners worked overtime, recalculating trajectories to point their instruments at this fleeting target. The comet was moving at a speed no solar system object could match, a ghost passing through the Martian sky. The opportunity was historic, but it was also incredibly brief. The promise of Mars. This was never just about getting a cool picture. This alignment was a once-in-a-generation chance to answer some of the biggest questions in planetary science. Having a world-class laboratory already in orbit around Mars meant we could study 3I Atlas in ways impossible from Earth. Think about it, the Mars Reconnaissance Orbiter's high-rise camera could potentially see the comet's nucleus or any fragments breaking off. Spectrometers like Omega on Mars Express or the Nomad instrument on the Trace Gas Orbiter were ready to taste the comet's atmosphere. Dr. Nicholas Thomas, who leads the team for the CASIS camera, knows these instruments are sensitive enough to detect the unique chemical fingerprints of interstellar ice. Are the building blocks of life the same in other star systems? Is the water in this comet similar to ours? These instruments were designed to answer exactly those questions by analyzing the gases in the coma. It was a chance to perform a chemical autopsy on a pristine sample from another star system, testing every theory we have about how planets are made. Every asset was pushed to its absolute limit for this cosmic flyby. A faint signal emerges. With the world's major space agencies completely silent, the first piece of evidence came from where nobody expected it, the public data archives. Working independently, two citizen scientists known for their meticulous work processing raw space images made the first confirmation. One of them was Kevin M. Gill, a software engineer at JPL who is famous in space circles for turning raw data into art and science. They downloaded the public Mastcam Z images from the Perseverance rover just hours after they arrived on Earth. The process was painstaking. They took dozens of long-exposure images of the Martian night sky, carefully aligned them using the background stars, and then used complex algorithms to subtract the immense noise. And then, they saw it. At the exact predicted coordinates for 3I Atlas, a faint, diffuse patch of light emerged from the static. It is not a dramatic photo. It is a subtle, slightly smeared glow, but it is real. They released their findings cautiously, sharing their annotated images and the code they used so anyone could verify their work. It was a testament to open data and persistent curiosity. The auditable path. Seeing a faint smudge in an image is one thing, proving it is an interstellar comet and not just noise is another challenge entirely. The path to this detection had to be auditable, meaning every step was documented and reproducible. The analysts started with raw, 29-second exposures from Perseverance's Mastcam Z camera. The principal investigator for this camera, Dr. Jim Bell, designed it for incredible scientific precision. For each image, the team had to find a matching dark frame, an image taken with the lens cap on, to map out and subtract the camera sensor's inherent electronic noise. Then came flat field corrections to account for dust on the lens and variations in pixel sensitivity. Next, they had to align, or register, each image with sub-pixel accuracy against a star catalog. Only then could they stack the dozens of cleaned frames. They used multiple methods to combine the images, which boosts the signal of a faint object while averaging out random noise. The final step was to model and subtract the Martian sky's background glow. What was left was the detection, a signal statistically strong enough to be real. This wasn't guesswork, it was a forensic process. Viral myths and reality checks. The moment the legitimate faint signal began to circulate, the internet did what it does best. It found fakes that were far more exciting. The most viral was a sharp bright streak in a Perseverance navcam image from October 3rd. People claimed it was the comet, clearly visible and dramatic. But seasoned analysts immediately grew skeptical. Planetary geologist Emily Lakdawala, known for her forensic checks of space images, ran the numbers. She plugged the image time and coordinates into JPL's Horizon system, the gold standard for locating objects in the solar system. The streak's path, speed, and timing perfectly matched Phobos, Mars's inner moon, caught during a long exposure. It was a classic case of mistaken identity. Another claim centered on a different bright streak, but analysts quickly showed it was moving at least 10 times faster than the comet's predicted speed across the sky. It was likely a meteor, or a cosmic ray hitting the sensor. Emily and others methodically debunked these claims, showing side-by-side comparisons of the fake streaks versus the comet's actual predicted path. The lesson was clear. In the age of instant analysis, rigorous verification matters more than ever. The silent orbiters. So, where were the multi-billion-dollar orbital missions while citizen scientists were making the only public detection? The silence is what makes this story so strange. Let's be clear about what we are missing. The Mars Reconnaissance Orbiter carries the HiRISE camera, a telescopic instrument so powerful it can spot a coffee table on the Martian surface from 300 kilometers up. Its principal investigator, Dr. Alfred McEwen, and his team could have delivered the sharpest image of an interstellar object ever seen. The ESA's orbiters were ready to perform a chemical analysis. The trace gas orbiter can detect atmospheric gases in trace amounts. If 3I/Atlas was venting anything unusual, any molecule not seen in our own comets, it would have found it. The UAE's HOPE and China's Tianwen-1 were also observing, providing a global network of coverage. The potential for a breakthrough was immense. Yet, as of today, not a single raw image, spectrum, or even a low-resolution thumbnail has been released to the public. The data is either under embargo, stuck in a processing queue, or something else is going on. The knife's edge. Pointing a deep space orbiter is not like using a DSLR. It's really an exercise in calculated risk, operating on what engineers call the knife's edge. The predicted position of 3I Atlas, its ephemeris, was constantly being updated. Each orbiter had to be slewed or turned to point at a patch of empty sky, just hoping the comet would arrive on schedule. There's no real-time joystick here. The commands are sent hours in advance, and the spacecraft executes them autonomously. Honestly, it's a leap of faith. The entire observation might hinge on a prediction that was off by just a fraction of a degree. Then there's the Deep Space Network, the communication lifeline to Earth. According to Dr. Lori Glaze, NASA's head of planetary science, bandwidth is a precious resource. All of NASA's Mars missions, plus international partners, have to share time. So, even if an orbiter captured a perfect image, that data might sit in its onboard memory for days, just waiting in line behind higher priority health and safety telemetry. A missed pointing window or a delayed downlink could mean the difference between a historic image and a frame full of empty space. Blinded by the sun. Just as the mystery of the missing data deepened, the curtain came down on any new observations from Earth. And this isn't a conspiracy, it is orbital mechanics. As October advances, 3I Atlas is approaching what is called superior conjunction, when it passes almost directly behind the sun from our perspective. This celestial alignment, happening around October 21st and 22nd, effectively blinds us. The sun's overwhelming glare makes it impossible for any ground-based or near-Earth telescope to safely observe the comet. The comet's most active phase, its closest approach to the sun, or perihelion, happens on October 29th, right in the middle of this blackout. As Dr. Michael S.P. Kelly has noted in his research, this is the most critical time to observe a comet for outbursts. It is when the comet should be at its most dynamic, and we are completely unable to watch. This blackout will last until early December, so, for now, the The silence from the Mars orbiters is compounded by a physical barrier. The universe itself has blocked our view, leaving us to wonder what is happening in the glare. The working hypothesis. Before the data blackout and the mysterious silence, what did scientists actually think 3I Atlas was? Based on early observations, a working hypothesis had formed. The evidence suggested it was a natural interstellar comet, not an artificial object like some had speculated about Oumuamua. Its behavior was broadly comet-like. Analysis of its light signature pointed to a composition rich in carbon dioxide gas. What was more interesting was what seemed to be missing. Like the previous interstellar visitor, 2I Borisov, which was studied extensively by scientists like Dr. Denis Bodowitz, 3I Atlas appeared to be depleted in dicarbon. This is the molecule that gives most solar system comets their classic green coma. Its absence suggests a different chemistry, born in a different kind of stellar nursery. Some early unconfirmed spectra even hinted at an excess of certain metals, like nickel. But all of this remains provisional. Without the high-fidelity spectra from the Mars orbiters, this hypothesis is just an educated guess. The final word on the comet's chemistry is locked away in the very data we are all waiting for. What remains and what comes next? The data from the Mars flyby might be out of reach for now, but the story is not over. There are a few long-shot possibilities for observation during the solar conjunction blackout. The SOHO spacecraft, which constantly stares at the sun, has a coronagraph called LASCO C3 that might catch a glimpse of the comet. It is not very sensitive, so it would only see 3I Atlas if the comet had a major outburst and brightened dramatically. Farther out in the solar system, the European Space Agency's JUICE spacecraft is on its way to Jupiter. Experts like Dr. Geraint Jones have confirmed that there might be a brief window in early November where JUICE could try to image the comet, but the real action will begin in late November or early December. That is when Earth's motion carries us out of the solar glare, and ground-based telescopes can finally get back in the game. When that happens, expect every major observatory to be pointed at the patch of sky, trying to recover the faint, receding visitor. Until then, the only confirmed public detection remains that single faint stack of images from Perseverance. So, here we are. We stand on the edge of a potentially historic discovery, armed with more questions than answers. The only public evidence of 3I Atlas's Martian encounter is a faint signal teased from public data by curious minds, while the most powerful instruments in the solar system remain mysteriously silent. Is this a simple case of bureaucratic delay and the unforgiving realities of deep space communication? Or is the data so groundbreaking that it requires absolute certainty before being revealed? The truth is locked on a hard drive millions of miles away. What we do know is that the universe sent us another postcard from a distant star, and we are still waiting to read it. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our cosmos. Thanks for watching Future Facts.